Alright, so now we want to look at, the book talks about ratio, sort of ratio versus rate of change, and I think we need to talk about that here a little bit, in that what they say is when you're looking at this slope, right, we're saying slope, and we have our delta y over delta x, or it's for tiny enough things, generally a change in f over change in x, as long as these are nice functions and so forth. Very bad deltas there, but so they want to say that the slope is a ratio if the units of y and x are the same. So if x and y units match, the book, what they're saying is this is a ratio. Well, that's true. They're not lying to us. And then they say if x and y units don't match, then they're calling it a rate of change. Well, again, that's true. But actually, they're all rates of change. Because a big thing in math, a lot of what we'll do with functions, we don't have units at all, and so all of a sudden the book will be talking about rates of change, but technically, well, the units match in that they don't have any units, and so it's a ratio, and they're trying to draw a line or a difference, but that's just silly. So, as an example of why that's just sort of silly is look at their example 2. On page 12 of your text, and they have this, they're looking at an actual case of, okay, I've got a 24-foot ramp, well, it goes horizontally 24 feet and goes up 22 inches. Now, why they couldn't go with 24 inches, I don't know, but anyway, it goes up 22 inches. And so if we take the change in y over change in x, it went up 22 inches over 24 feet. So they're saying if I write it that way, I get, what is this, 11/12? 11/12 inches per foot. Okay, and they're saying, hey, that's a rate of change. Okay, so rate of change. Okay, well, it's also a ratio of two things. The units don't match, but it's still a ratio in that we're taking 22 inches divided by 24 inches, or going up 22 inches for every 24 feet we go over. That's still a ratio too, and so I wouldn't get too hung up on that sort of thing, but it's definitely a rate of change, and that's what we're most interested in, is we want to talk about rate of change. Now, in their example though, they changed the 24 feet to inches, and so they would say, oh, delta y or delta x is 22 inches over however many feet this was, 288, or sorry, inches. And there the units match, and so they're saying, oh, that's, and I'll use their number, 0.076, I think. And they say, well, see, that's a ratio because the units cancel out. Inches over inches is just 1. Well, except I can still write the units. I can say inches per inch. And actually that's a perfectly good unit and looks like a rate of change to me. Okay, because they're saying sort of this idea when you start saying something per something else, you know, per unit change, you know, so this is up here, it's going to be 11/12 inches change per unit change in the bottom. Well, that unit change is 1 foot. And here it's 0.076 inches change per unit change in the bottom, but the unit change in the bottom is inches. And so inches per inch. Well, that's perfectly good. That's a rate of change. So don't get hung up on, well, is it a ratio or a rate of change? Yeah, we want to talk about rates of change, and they're all rates of change, whether the units match or not. So yeah, just you don't want to get hung up on that. And I think that's all I really wanted to talk about with the rates of change versus ratio and the units of slope. Again, just we've got the units of the top or the y-axis divided by the units of the x-axis, and so the per is telling us divided by. So that's it for that one.